chat with him. And now let's take Noam here. Hey, Noam.
Hello.
I'm super excited to have you here for the keynote of DevSecCon. Yeah, good code, bad OpSec, data horror stories from a hacker's perspective. For me, after 1 year of listening to Darknet Diaries, I'm very honored to run this track. So let's have your awesome talk, and then we'll chat a bit.
Looking forward.
See ya.
Okay, so hi, my name is Noam Rote, and I'm here to talk about DevOps mistakes, bad OpSec that led to a lot of data leaking out, going sometimes public, and having very bad consequences to whoever was in charge of this data. So a little bit about me. I've been building stuff for over 35 years, and I've been breaking stuff for over 30 years. This year, I founded another company, VC-backed, called Hyperguest, and I'm acting as a CTO, same role I've been doing for the past 15 years in various industries. Another fun thing I do is I run a few side projects with a few friends. Hello, Mr. Locar, detecting data leaks. We found a lot of biometric information, millions of records, the US drone systems. We became administrators of a few jails in the US and found ourselves in the networks of more than a few Fortune 500 companies. We also found nation-level data for countries like Ecuador, Chile, the US, India, and Israel. And when I'm saying nation-level data, I'm talking about all of the data, financial, insurance, cars, everything you can think of. And I have a warm place in my heart for the Israeli network security, or lack thereof, which I'm sure we are all aware of. And last thing about me, I like pastries, and I was promised pastries if I speak here. So when we talk about data breaches, basically it's like a huge pyramid. The tip at the top is about broken technology. Ciphers that are broken, protocols that are mishandled, but the vast majority of issues are human errors. We are all developers, we do DevOps, we have bugs. The question is, do we catch these bugs before they go live? In most cases, as we will see shortly, we don't. And there is another layer that is caused by malicious people who are doing phishing and installing ransomwares and threatening to do things. But again, from everything we saw in the past few years, a lot of it can be attributed to human errors. And this is what we are going to talk about today, the OpSec that is required to prevent this. So I'm building a new system. I'm doing everything by the book. I set a VPC, a virtual private network, with a single endpoint, which is a load balancer. I have a few servers inside, and I have a database with secret information I want to protect. I even went out of my way and I installed a firewall or even a WAF. I've made sure my developers are writing secure code. I manage my code securely, and I have a separate QA environment. Everyone would say Good job, Noam. No one will take your data. Today, I want to talk about top 10 common mistakes that a lot of us are doing, and it's quite easy to prevent them. So I hope after this talk, you'll go back and revisit your code. So the first thing that is commonly encountered when dealing with data leaks is lazy developers. Now, we are all developers, we all write code. Many of us are lazy. So in order to prevent our laziness to reflect itself in leaked data, we have to have policies. We have to have strict password policies. We have to have strict security policies that will prevent other people from exploiting our laziness and entering our network. A good example would be a huge company, which I will not name, that I was hired to look into their network. Now, they really did a good job in securing their network. I sat with the CISO, who boasted that I would need 300 years to break into his account because even he doesn't have access to all of the information. Inside, I was laughing because I already had all of his information in my small laptop. And how did this happen? One of his developers used the password 123456. And this developer, because he was lazy, gave himself root permissions. So by guessing a very simple password, I got access to all of the private information, very sensitive information of this very, very big company who raised a few hundred of millions of dollars. By having strict policies that would prevent idiotic passwords like 123456, this developer would have to go the extra mile and put in a harder password. I would have a harder time in guessing. Same things with common logins. On your production environment, you do not need a QA user called QA at my domain. On your production environment, you must have two-factor authentication for at least root users or users with greater permissions than others. On your production environment, you cannot hard code your passwords, your keys. Everything needs to be set up in a way that it cannot be exfoliated. So we've all met the lazy developers. It is our job as platform architects, platform engineers, security architects, to make sure this laziness will not cause us too much problems down the line. A very, very, very common mistake that we encounter is logging. So if we take the little diagram we had before of my VPC with the load balancer, one entry point, now my management is coming and telling me we need better logs. We need more logs. So the easiest thing to do is take a logging service and start dumping everything inside. What we see that in many, many cases, since it's internal logging, no one bothers to put authentication on top of it. So when you are logging access to the private users' wallets, you write the private key and the wallet address. You'd be surprised how many cryptocurrency exchanges use this solution to expose their clients' wallets. So even for internal purposes, you must have authentication. Even if it will cost another millisecond doing the connection, it's worth it, trust me. Another thing that we see is people putting the logging server outside of the VPC, so it will be easier for them to run a BI on top of it. Another very, very serious mistake that people are doing is logging in the wrong place. When you are PCI compliant, for example, you are not allowed to save plain text credit card data. But when you are writing the logs, when you are sending the credit card number, when you are receiving credit card numbers, you save the entire request. So by not having maskers on top of your logging service, you basically break your own standards. So a logging service, which seems like a very, very simple, very, very straightforward task, can be a huge security hole. And we've seen so many of them that are exposing the entire client requests with headers. Or, when you forget your password and you are being emailed a password reset link, this link. Or outgoing API calls for external services are being logged with your credentials. Database connection string, infrastructure keys to access S3 buckets or whatever. Everything is exposed. We saw it in many cases. For example, GearBest, a very big Chinese e-commerce website, did exactly this, masked nothing, logged everything, and forgot to put a password. So not masking sensitive data is one thing. Another question you need to ask yourself, do you need the PII, the user names, email, addresses, whatever, to be saved in the logs? Will it give you anything by saving this? Because it's one thing that your logging system is leaking, but if there is no sensitive data inside, no harm done, except for the developer that needs to get a newspaper on their nose. And the last thing is that usually these logging services don't have the logs of their own, so they don't know who accessed them. So make sure you have authentication, you have logs to know when data is being stolen from you, and make sure that everything you save inside is stuff you really need to save inside. Number 3 on our list is our backups, migration, and dumps. Oh my. We take our schema again. We have our VPC. We have our log server. Let's say it's now secure. But now my QA is saying that their environment is not up to date. And some of the data that they are testing does not reflect exactly the production data. What does a lady developer do? They dump the production database, they move it to the QA environment or to their local environment and work on it there. Alas, the security on the QA environment or their local environment is not as good. And in many cases, they just leave the dumped data file on the production environment publicly accessible. I cannot tell you how many times I found these kinds of dumps that basically gave me everything I needed, even though the systems themselves, the code was built very securely, everything was in place, but they gave me a present in the form of a wrapped up database with all of their customer information. Another thing that we see in many cases, when one company is being moved, is being bought by a larger corporation, is being merged into another operation, they are moving their infrastructure. So they are creating migration pipelines to get data from one place to another until they drain it out and close it. And in many cases, these pipelines are not secure, or they are just left open. So we can see everything inside. What happened in Ecuador, for example, there was a huge Hadoop cluster that moved data from government servers to different servers. And this Hadoop cluster was open. So all of the migration data was exposed with all of the very, very private information of all the citizens of Ecuador. So finished with the migration, close it. Doing the migration, protect it. Number 4, and this is a personal favorite, code management. In many cases, the initial design, it doesn't have to be of the main system, but even an internal system, a CRM system to manage customer contacts, or whatever is written in a less professional way. And the directory structure puts the public directory on the root directory. Now, one of my scanners is scanning for Git directories or SVN directories or any other code management repositories, basically. When I find one, I just dump everything, and I have all of the structure, all of the code, and in many cases also history. Looking at a repository configuration file can reveal more information like developer emails, sometimes passwords, sometimes more endpoints that are accessible from outside. So it's a lot of fun. And just in India today, there are over 20,000 systems with exposed Git directories. In Israel, the number is in the hundreds. So looking for some fun, look for exposed Git directories, looking to protect your data, move the public directory from your root so the code management will not be exposed. Also, if you are running your own GitLab, for example, for your own company, make sure you understand how it works. For example, in many GitLab's installations, even those who require a username and password, you can just go to /explore and see a lot of repositories that are there. You can also register if it is not blocked. So just by registering to an organization, to an open GitLab, you can gain access to a lot of private repositories that you should not have access to in the first place. Another code management woe is code dumps. We talked about data dumps. Code dumps are basically the same. Lazy developers uploading code or packing code in order to download it and leaving it with a silly name like backup.gz or backup zip or back.zip or any other variation of what you would expect a lazy developer to call a packed version of the entire code. Now, this, in many cases, include customer information because it packs everything. It includes environment files with passwords and keys, and a lot of other information that is always fun. So the code repository must be protected at least or even more than your production environment. Number 5 is saving money in the wrong places. If we take the lovely network diagram that we saw earlier, we have our production environment, and suddenly there is a very, very important marketing effort that needs to be taken online on Thursday at 6 o'clock. So the lazy developer, the lazy DevOps, takes the server, puts it inside the VPC, and puts another load balancer on top of it. And this server connects directly to the database with all of the production information. Now you'd say, who would do such a thing? There's a small company called Amadeus, who runs approximately 500 millions of reservation. I don't remember if it's each month or each year, but it's a lot of data. They had a very, very good production environment and a very, very bad marketing website. Through this marketing website, who sat on top of the same production database, hackers were able to access the production database while bypassing all of the very expensive protections put in by Amadeus. In many cases, the marketing website or any other minor system is being outsourced, many times to drunk limos. And these people are paid peanuts and perform like monkeys. The code is not secure, and the fact that you invest all of this money to protect your environment and then putting in a drunk lemur to take all of this data outside is just not worth it. So make sure that all of your properties are properly developed, properly audited before putting them on the production environment, and separate your production environment from your marketing environment. Another fun thing that we do is look at bad resource management. You have a website and you have all of the images of the website and the icons, and you put it in a bucket. This bucket, which can be accessible with a CDN, this is very good practice. It reduces the load from your system. It increases the performance that your users enjoy. But if done improperly, can expose you to additional risks. For example, using the same bucket for your images and icons and your management reports. Sounds like a good idea? No. How many buckets are there with this kind of configurations? Hundreds of thousands. Another common mistake is exposing the bucket or the cloud storage that is holding this information with what is equivalent to directory listing. And while having a CDN load the files from the cloud storage, still allow access to the cloud storage. So when using cloud storage buckets or whatever you use, make sure it is at least as secure as the rest of your servers. Never allow direct access to it. Best practice, by the way, is to all of the PII, all of the reports, all of the sensitive information to be accessible only through your code and not through CDN, although it sounds like a fun shortcut. And make sure that the file names that you use are not lazy. Use unique IDs. Don't put the user ID or any other auto-increment number on the files, because so many systems are doing it, and so many systems are exposing their users to this kind of mistreatment. A fun thing we learned with the Twitter hack that happened earlier this year is that communication between the development teams is very, very important. In order to secure a lot of your systems, it is very wise to invest in OpSec training to all of the employees. And I'm not talking only about developers, but also for management, logistics, operations, finance. Everyone who has access to client information must at least be aware of the OpSec dangers that they may face. So if a developer gets a call in the middle of the night or gets a text saying, hey, I forgot the password to the BI server, they need to know they should never give this information, even if it's their best friend texting them, because they don't know if it is the friend. So by having policies saying never, ever, ever send passwords, you reduce the risk of an employee allowing access to your secure environment. Having better two-factor authentication for employees is a bonus. But if employees don't know what they should be aware of, they will obviously be more susceptible to leaking information they should not. Also, for chat services, if you use Slack, if you use any other internal communication, think really hard. Do you need to save everything forever? While it's fun, having someone access to the entire chat history of your entire development team may not be the best idea. Number 8, also a fun one, unrefined permissions. If you remember earlier this year, the entire voter registration information for every citizen in Israel was leaked. Why did it happen? It was because that the credentials used by the application developed by elector was root permissions. It gave access to their entire AWS account, including everything: user management, RDS, files, servers, load balancers, everything. When you need to perform a specific task, you need to think about security and add a very, very refined role. Otherwise, you are exposing yourself to things like the entire voter registry of Israel. You need to never use root permissions. You need to put measures in place to prevent the usage of root permissions and report it, so you will be at least aware that someone is trying to bypass your policies. So when talking about permissions, the less, the better. Common mistake number 9, which is closely related to common mistake number 10 that we will see shortly, is the 30-centimeter vulnerability, which is the length that the user is sitting near the screen. Users, internal users, in many cases, are your worst enemies. So, like you don't trust anyone outside of the organization, thinking about security leads you to never trust anyone inside the organization as well. So without good endpoint security installed on the machines of everyone in the organization, you will never know that something is happening. Without constantly monitoring anomalies in accessing your backend, in accessing your files, just the traffic even, you will never know it. Without proper phishing protection on your own email servers, you will never know someone is even trying to get the information out of your systems. And without good social engineering training, your employees will not be in a place to even report attempts to take your data. So, like you don't trust anyone that is outside of your network, you should treat the internal of your network the same. So my favorite part, and this is common mistake number 10, we'll call it common bad judgment. So bad judgment can be unintentional, like the Palestinian power company, which had a lovely administrative system which controlled the entire power distribution for the West Bank and East Jerusalem. And what they had a lovely login page, but you didn't have to go through it. You can just go to the next step and be an administrator. There was absolutely no check whether you are logged in or not to the back office. So it's unintentional. It's definitely a backdoor because it allowed access to all of the customer information. And it should not be there. It's bad judgment. Another type of bad judgment is intentional front doors, like happened in the elector system, which leaked the entire Israeli voter registration. What happened there? There was an endpoint that you would call. This endpoint appeared on the client-side code, and once you called it, you got the entire configuration file, which included private keys, private root keys, as we saw before, administrator phone numbers, passwords, other backdoors that were there. So calling it a backdoor, not really accurate. It's literally leaving your front door open and spreading out leaflets all around town, welcoming people to take your data. Another common bad judgment is just hard coding keys or exposing keys in client-facing codes. It can be your JavaScript code that is accessible to clients, sometimes even your HTML code, and it can be your APK, your Android package that we found credit card information hard-coded inside the APK. When we contacted the company that exposed it, they told us, yeah, it belongs to our CEO. So don't expose any keys or authentication methods on your client-facing code, because curious people will want to see it. Uploading your keys to public repositories. There's a very good company here in Israel who is managing some of their code as open source. Now, it takes seconds between a mistake made by a developer that uploaded their AWS keys or Google Cloud keys to GitHub and the time it was used. You go to lunch, you go back, you have a cloud bill of $10,000 and growing, just because one developer uploaded their keys. So having good CI/CD processes, having good code management, having filters and warnings before pushing your code to any repo, doesn't have to be public, it can even be private, is always a good idea. Fail your code if it exposes any information that should not be there, and it will pay off. There's also something called code smell. Code smell, when you are a developer for enough time, you look at the code and you know something is wrong with it. In the Israeli prison service, for example, just by looking at the code, you saw something smells. The first function a developer writes, they put their name on it, David. The second function will do what the function does, like read, document, or whatever. On the Israeli prison services system, the function was called David. And any developer looking at such a code knows that this system is leaking, and this system is leaking so bad, it can take up to 30 seconds to get all of the information inside. Now, what happens there, it didn't end with a function named David. It gave direct access to the database with the plain text passwords being 1, 2, 3 for the administrator of the Israeli prison service. And from there, it took one click to download thousands and thousands of very private and sensitive information of Israeli prison services employees, other security organizations, credentials, documents, private medical information. And just because one developer called their function David. So make sure that you do proper reviews to prevent this common. Everything we discussed here can be prevented by having proper policies, proper reviews, and proper audits of everything you are doing. By following very simple guidelines, you can protect yourself, your company, and your customers' data. So to sum up, OpSec is not complicated. OpSec is boring. It's much more fun to develop new things, to run forward, to create, but it is less secure. So by following protocols, by setting protocols, and making sure everyone in the company, from the first developer to the last cleaning person, follow these protocols, you will protect yourself, you will protect your company, and you will protect your customers. Thank you very much.
Hey, Rote, Noam, thank you very much. It was an awesome talk. And now, after describing the most widely spread industry standards that we see all over. We got a question. What did you find helpful to make developers successful in terms of security topics?
So, for my experience, and I've been doing it for a while, education. Education is the key. Tell your developers how to hack so they know how to protect themselves from being hacked. If they are not aware of specific techniques, if they are not aware of specific technologies, if they are not aware of specific attacks, when they develop code, they will fail. The code will fail and the data will be exposed. So it's really not a big investment. A few hours, teach your developers to hack. It will obviously produce better code later. And they will also notice things that are currently going unnoticed. They will start to report things that they are not reporting today. They will start to see things in other systems, maybe third-party systems that endanger your data. So if you ask me, the one thing you need to do to protect your system, educate your developers.
Yeah, I will add that it should be not only developers, but also operators and all staff that has all access, because we know a lot of very fun stories of cleaning managers and other people who had full access to server rooms. So yeah, thank you very much. It was super nice. Bye, Noam.
Bye, Andre.